start with our exercise 7.2 in cubes and cube roots. Now 7.2 basically deals with finding cubes and cube roots. So here we have to find cube root using prime factorization method. Prime factorization, like I have already told you how a number is factorized. We find the prime numbers which could divide that particular number. So let's see. This is our number. 1,10,592. 110,592. A big number, that's why a big prime factorization which cannot fit in here, so it's extended over there. So this continuation is here, so continue it after this. So 1,10,592. So when it's an even number, so divided by 5 you get 55,296. Then again it's an even number, so divided by 2 you get 27,648. Again divided by 2, because it's an even number, we get 13,824. Again divided by 2, 6,912. Then again divided by 2, 3,456. Again divided by 2, 1,728. Again divided by 2, 864. Again divided by 2, you get 432. Once more you divide it by 2, you get 216. Once more you have to divide by 2 because it's an even number, so you get 108. Again division by 2 gives you 54. And after division by 2 you get 27. Now 27 is not an even number, so we see the next number, that is next prime number, that is 3. And since 27 is divisible by 3, we take 3, and then 3 divides 27, you get 9. Again 9 is divided by 3, you get 3. 3 is divided by 3, you get 1. This is how we have factorized it. Now next, to find the cube root, we make groups of 3. Now groups of 3 means 3 here, then 3 more, then 3, then 3, and then 3. 3 numbers, the same numbers have to be grouped. Alright, and from groups we take 1 each. So out of this group we take 1, out of this group we take 1, out of this group we took 1, this 1 and that 1. Alright, so 2 into 2 into 2 into 2 into 3. This is what we have to find. Now this gives you 48 as your answer. So cube root of 1,10,592 is 48. This is how we would find the cube root of a number using prime factorization. Now we have already studied the table of the numbers, and I had already notified that the number which is even will have even cube, the number which is odd will have odd cube. So odd number and even cube is not possible, so it's a false. Perfect cube does not end with 2 zeros. That is absolutely true. Because we see 100 is not a perfect cube. It's a perfect square, but it's not a perfect cube. Perfect cube has to have multiples of 3 as the number of zeros. 3 zeros or 6 zeros or 9 zeros, that should be there. Otherwise, the number is not a perfect cube. So this is true. If a square of a number ends with 5, then its cube ends with 25. Square of a number ends with 5. Square of any number with 5 is not possible, because always you see 25 is there in the tail end. And here cube ends with 25. That is not possible, because square ends with 25, not cube. There is no perfect cube which ends with 8. False again, because we have perfect cube which ends with 8. 2 cube is 8. So false. Cube of a 2-digit number may be 3-digit number. 2-digit number may be a 3-digit number. How can it be possible? It won't be possible. Because see, at 9 itself we get the cube of number 9 is the last 3-digit cube. After that, cube of 10, that is 2-digit number, gives you 1000. So it is not a possibility. 2-digit number with 3-digit cube is not possible. Cube of a 2-digit number may have 7 or more digits. 2-digit number cannot have 7 digits, because 3 and 3, the number of digits in cubes have to be multiple of 3. So if there are 2 digits, then there will be 6, not 7 or 8. The cube of a single digit number may be single digit number. That is true, because 1 cube is 1, 2 cube is 8. Till there it is absolutely true. After that it is not a truth. But then, since there are certain exceptional cases, so we have to mark it as true. Now here you are told that 1331 is a perfect cube. Can you guess without factorization what its cube root? What is its cube root? Similarly, guess the cube roots of 4913, 12167 and the 2768. Now here we are going to use guesswork. How to make the guess at the cube roots. First step would be making groups of 3. Like we have done for square roots in division method, we made groups of 2. Here, since it's cube root, we have to make groups of 3. So from the right hand side, you make groups of 3. So here there is 3 and here there is 1 number. So 1 in the units place. Which cube from 0 to 9 has 1 in the units place? It's 1. So 1. So 1, the last digit, the digit in the units place is 1. And the 1, why 1? Now cubes, you see the cubes. 0, then we have 1, then we have 8, then we have 27, then we have 64, 125, 216, so on. Now here 1. 1 lies between which 2 cubes? That we have to guess. Which are the 2 cubes which come before and after this? So 0 cube is 0 and 1 cube is 1. Alright. So the bigger number is, so what's the exact number there? 1. So that's why the number in 1/10's place is 1. That's how we could guess. Now let's take another number, 4913. Now we have to guess at the cube root. So groups of 3 from this side and 1 on this side. So which cube has 3 in 1's place? 7 cube, 343. So 3 is there in 1's place. So 7 is in 1's place in this cube root. Then 4. Now which 2 cubes are there before and after this 4? So before 4, 1, and after 4 we have 8. 1 and 8 are the 2 cubes in between which this number 4 lies. So what we could say, the smaller number has to be taken. Smaller number here is 1. So 1 is in 1's place. This is simple guesswork, but you can verify it using prime factorization. Now likewise, you see here 3 digits here and then 2 here. So 167. Now which cube has 7 in 1's place? 3 cube. 3 cube 27. So 3 in 1's place. After that 12. Now which 2 cubes come before and after this? Because 12 is not a perfect cube. If it were perfect cube, we would directly take that number. But since 12 is not a perfect cube, we are going to see which comes before and after this. Alright. So the cube between which this number 12 lies is 8 and 27. 2 cube 8 and 3 cube 27. Between these two numbers, this 12 comes. So which is a smaller one? 2. So we put 2 there. Then 768. 8 in ones place. Cube of which number has 8? 2. So directly we take 2. Now 32. 32 lies between which two cubes? The cube in between which it lies is 3 cube 27 and 4 cube 64. So 2 cube is 27. So it is closer or and smaller to that. So we take 3. 32. We take the smaller cube. So 32 is the cube root of this number. This is guessing at the cube root. But then it is absolutely correct. You could verify it using prime factorization method. With that we come to the end of the chapter. Have a good day.